Hello.
Hello.
Hey, I'm so sorry. There were some internet issues. I was not able to join earlier. Can you hear me, by the way?
Yes, yeah, no problem. Yeah.
All right. Okay, cool. How are you doing too?
Good, good. How are you?
I'm doing good as well. Just some internet gripes that I have today. That's all. But yeah,
Yeah.
doing good as well. Thank you. Have you done these interviews before? Mock interviews on the platform or otherwise any mock interviews elsewhere?
Yes, I've used this platform before. Yes.
Gotcha. Cool. And do you have any interviews coming up with Meta anytime soon?
Yes. In a week, I have my first phone screen
Oh, okay.
with Facebook or Meta. Yeah.
Gotcha. Okay, cool. All right. And do you want to tell anything about your years of experience, what level you're aiming for, anything like that? Do you have any of that
Uh,
information?
yeah, definitely. So I'm a software engineer. I have 2 years experience,
Mm-hmm.
and I am interviewing at Meta for I think it's a general one which is for E3 or E4.
Right,
It
okay.
depends. Yeah, and I was told that my first interview going to be a 45 minutes
Yep,
phone screen with two problems.
yep.
So my goal is like I would like to um, get the same experience like as close as possible from this, as real as possible from this mock interview,
Mm-hmm.
and also get feedback from you. So I want to know where I am standing now, how
Yep.
far I am from that interview to be successful about that interview. And yeah, any feedback if you can in the end give me in order to, I can become prepared for the interview. And
Yep.
possibly, if I'm very far away from the phone screen, I'm going to postpone it. Hopefully, I can
Gotcha.
do it. Yeah.
That makes sense. That's my job as well here, so I'm gonna try to keep it as realistic as possible. I've taken now more than 40 interviews for the company for Meta. So I think yeah, and these are all coding interviews that I'm talking about. So should be able to give you a pretty realistic picture. Now about that 45-minute round, just to kind of tell you about the structure, it's divided into three parts. So it's 5 minutes initially for introduction, followed by 35 minutes for the actual problem solving, followed by 5 minutes at the end where you can ask any questions you might have.
Hmm.
One thing that I suggest, the start itself, especially here on this platform, is really don't waste any time for introduction. So you can try to keep your introduction as short as possible. As interviewers, we do the same, especially in coding rounds, because in coding rounds, really your background or any information about that you're going to tell us does not matter, and we cannot really judge you based on that. The only
Hmm.
metric on which we have to judge you is just how well you perform in the coding round, on the problem solving basically. So
Hmm.
if you kind of save yourself a few minutes of introduction, if you just say something which lasts maybe like 30 seconds or less, you can get 3 to 4 minutes from the introduction part for problem solving. So you can end up getting close to 40 minutes for solving the problems instead of just 35. Now, another thing is that you should know about is that you are expected to solve two problems, not one. This is so we can get more signals around you. Now, something that I do is it's possible that the interviewer pivots the question. It's also possible that they don't. So this kind of depends upon how the candidate is performing and where they are and what kind of signals the interviewer is trying to extract. Okay. So what I tend to do is that if you have not had any major movement on the first question, I will change the question about 15 to 20 minutes. The reason being giving you another chance basically with the second question and not letting all the 40 minutes just go away.
Hmm.
But different interviewers look for um, like there can be an interviewer who might want to just discuss the first question for a longer time with you, just to extract the signal of, if it's at a place where they feel that you will be able to crack it, then they might keep going on. So there can be
Mm-hmm.
that difference. Okay. The idea would
Yeah.
still be that you should try to solve both the questions or get very close to solving both the questions completely. You will not be allowed to run the code, neither in the real interview, nor I'm going to allow you to do that here, even though the code execution is enabled on the platform. So just something to keep in mind. Which language would you code in today?
Python.
Okay, let me shift to Python. All right. Is there any other question that you have before we begin with the round?
No, that's good. Before we start that about the introduction, I think that was a very good point, very
Yeah.
good tip you gave me. So is it okay? I just said like, oh, I'm a software engineer with 2 years experience, like one
Yeah,
sentence. Is
yeah,
that
and
weird
if you,
or
yeah,
that's
that's
fine?
usually enough. You can add another line or so, just around if you're working on front end, back end, and what kind of system it is, or what that system does,
Mm-hmm.
right? Whatever you're currently working on, you can just add another, a small line about that. Yeah, that's all.
Mm-hmm. Okay, yeah, thank you.
Okay. All right. In that case, let's begin with your round. That's the first question. Can you see it? Pasted on line number
Yes,
two. Yeah. Okay.
yes. Okay. Given the head of a singular linked list, group all the nodes with odd indices together, followed by the nodes with even indices, return the reordered list. Okay, so it's basically indexed by one. We started one. Second node is off. Okay, one input. Okay.
Right. So, just to kind of make sure that you've understood the problem correctly, how about you take a stab at telling me what would be the output if this was the test case?
um, yeah. So so it's gonna be 15937.
That's correct. Yeah. So that would be the answer. Yep. With that clear, I think now you can think of how we can solve this problem.
Yeah, sure. So to clarify it, my input is a head of a
Yep.
linked list.
Yeah, that's correct. Yeah.
And should I can I create a new linked list and return it, or should I like modify the input?
Let's discuss both the solutions that you have in mind here.
Okay.
What would be the difference and why one would make sense over the other or not?
Yeah. Uh, and for my linked list is a singly linked list. It means like if I wanna just get how it is defined, it has a value,
Yep.
right?
Yep.
And it
And
has
just a next
index
point.
pointer.
Yeah, that's all you have. Yeah. You don't need to write down this entire thing. It's okay. I think it's understood that you will have this sort of a linked list and you can just
Okay, yeah, yeah.
maybe work with the method that you will have ultimately. Yeah.
Yeah, and so the value here doesn't matter. So should I expect that I always get a valid input? Like, could I get a null as an
Yeah,
input or
that's
not?
possible. It's possible that you get a null linked list.
Okay, can get null. So if I get null, it means there's nothing to do and just return it, right? That's
Mm-hmm.
one edge case. And the number of nodes can be anything, can be
Mm-hmm.
odd, can be even, I
Yeah.
assume. So I don't care about the value of the nodes.
Yeah.
So there is nothing for me to worry about that. So the very first simple solution come to my mind is I create a new linked list and return. and I can create this new linked list first, going through the linked list, one loop, go through it, and just select the odd indexed uh, nodes.
Mm-hmm.
And as I select them, I put them in my new linked list. For example, I create a new node. This is my new node,
Mm-hmm.
and has a next pointer. In this, my first iteration, I start with here. I'm
Mm-hmm.
here. Oh, this is odd. So I just add it here, and I move this two times,
Mm-hmm.
two steps, because I only select one after another. So it's going to be 5. And I do it again, another 2. I get 9. And now if I'm moving it, I'm out. So I know I'm done.
Mm-hmm.
And I do another one, another reset. This time I start with the second
Mm-hmm.
node, and I keep the do same thing. I click them and I move this pointer uh,
Right.
2 steps
Right.
until I'm out of bound,
Yeah.
and I return the new node dot next, which is
Mm-hmm.
gonna be the head of the element.
Gotcha. Is this like a completely new linked list, or were you like when you were connecting five after one, are you trying to change the pointer with attached with one, or is this like a new node which has value one?
So I'm this approach is a new. So every
Hmm.
time I make a new node, and it's completely a new linked list, and the input is not going to be changed. So
Gotcha. Okay.
that allows me that I go through the linked list 2 times without any problem.
Understood.
And
Understood.
this is
Yeah, go on.
so in terms of I want to think about the like how optimized it is. So in terms of time complexity, it's O of n is number of nodes in the linked list. In
Mm-hmm.
terms of the space complexity, it's also of n because I'm creating a brand new linked
Yeah,
list with the
yeah,
same link.
yeah.
Uh, so one other approach that I'm trying to get into is not create a new linked list, and how can I actually modify the pointers, next pointers of each node, and um, create the new one. So if I want to do that, let me have 2 pointers. One
Mm-hmm.
always point at the uh, odd nodes, the other one J points at the even ones.
Yeah.
Uh, so I know that the node after the even is always odd. So I can change I point to 5 here
Okay.
and 1.25. If I
Mm-hmm.
do that, I lose this pointer here.
That's true.
So I have, so I need, but then I can move my next I is gonna be 5. So it's
Mm-hmm.
fine because I did the pointer. So it's
Yeah.
gonna be to 5. Now I need to do the next one, which is J should point to 3, should point to 7. So I do the same thing. J always point to the next I.
Mm-hmm.
So it means I lose this pointer. And here I have 3.27. And then I now move the J to J next, which is going to be 7. And then I do the same thing for I. It means is 5.29.
Mm-hmm.
I lose this pointer, but I move 5 I dot next. It's going to be 9.
Mm-hmm.
And J again, which is going to be the node after I, which is null. So this is going to be to null. And move J out, and now I need to just make these two connect to each other,
Mm-hmm.
and 9 should connect to 3. So if I had a pointer here for 3
Mm-hmm.
for the head of the even ones, So I just connect these two together. So this is gonna be, I think, the better approach to not return the note. Obviously, the cases that I wanna be careful is not the length of the linked list. For example, so the thing is, either of these pointers, if they go out of bounds, I'm done. So first, if my first pointer is gonna be the head, the second pointer is gonna be the head.next, which is I'm gonna keep this pointer as the head of event linked list for in the end, so I can tie them together. Then I start loop until both pointers are not null. And as I do that, I always do one pointer to the next one. Start with the odd one. Start with P1. P1 dot next always gonna be P2 dot next, and then P1. I move the P1. So it's gonna be P1 dot next, and for the next iteration, I do it for P2, P1, and P2 at each iteration. So I just flip these to each iteration. One iteration P1, the other iteration P2. And in the end, P1 dot next is gonna be head of that head that I kept in the step 2.
Right.
Event linked list, and return actually the root or the first node from the input. I need to keep track of this also, the root. So in order, so I think this is like my algorithm. If it makes sense to you, I can start.
It makes sense to me. I think we can jump to coding this up. Yeah.
Call it reorder a linked list. I keep track of my root, and P1 is my odd, P2 is P1 dot next, and if here P1 doesn't exist, okay, so I know now I have actually P2, and while I have a flag, so I know which one I'm tying together in my while. First, I start with the odd. Well, P1 exists, and also P2 exists, and if it's time to do the odd one, I do. Okay, in this example, if I go again, P1 dot next is gonna be P2 dot next. Yeah, P1 dot next is gonna be P2 dot next. P1 is gonna be P1 dot next, and else is time for P2. P2.next is going to be P1.next, and now I move the P2 to the next one, and in the end I flip the turn, so it's not an odd turn anymore. So here I'm at step 4, and step 4 I'm gonna just tie them together. Okay, I forgot actually to do the step 2, which is saying keep the head of the even one.
Yeah.
Okay. So let's do even head. Now I have it here. So what I'm gonna do is P1. Let me see. P1 may be out of bound. One. If I have an example, if I have such a thing like this is P1, this is P2, P1 dot next is gonna be null, and then this is gonna be P1. So and then so one previous of the P1 should go to the actual head. So yeah, I want the previous node of P1 all the time. So let me first prove none, and here is gonna be P1, and then I move it. So in this example, prev P1 is gonna be 1, and then I do prev P1 to P2. Yeah. Not P1. P1 is gonna be even head. No, actually it is all the time. And then I return my root. So I think this is it. Let me just run one example to see if it works. So for example, if I have only two elements, P1, P2, and P1 and P2, first is odd, P1 dot next is gonna be null, P1 prev is gonna be 1. I'm out of the loop. And then in line 68, I do the prev, which is 1 dot next to 2. So it's gonna be 1, return the same, 1, 2. It's gonna return the same if it is 2 elements. And if it's 3 elements, P1, P2. So P1 is gonna be 1 next to 3. P1 is gonna be 3 now. Prev is gonna be 1. And then next element P2 is gonna be pointing to the next element of P1. It means we're gonna have 2 point to null, and I move the P2. P2 now is gonna be null, so I'm out of loop, and I'm out of loop, and now P1 1 should be 1 3 2. Yeah, so this is the bug. So if the P1 is out of the range, I use the prev P1. Otherwise, I use the P1.
Right.
next uh, so then P1 dot next is gonna be to the event head, which is 2. So it's gonna be 1, 3, 2. It's gonna return 1, 3, and 2.
Mm-hmm.
Uh, so I did 2 tests. One is for hot length, the other one for even length.
Yeah.
And for the length 0, I have an early return in line 53.
Mm-hmm.
So
Right.
I think this should be
Yeah, I think it looks good to me as well. Let's maybe jump to another question.
sure. Do you want me for the time complexity? Oh, that's fine. I think I did
I
it.
think you kind of implicitly discussed that when we were discussing this particular solution.
Yes, yeah.
I just pasted the question number 2 on line
Mhm.
number 89.
Yes, yes. Do you know how long, how much time is it left for me?
Yeah, so we have close to 21 minutes left.
Okay, sounds good. So given the root of a binary tree, return an array of the largest value in each row of the tree. Definition of the binary tree. So it has a value, has a left and right pointer, and tree node value left right pointer. Okay, so it's basically I have only one value in each node, left and right, and what I want to return is array of largest value in each row. Okay, so before I jump again, can I get like invalid input?
Yes?
Like, well, okay, so invalid input, it means like I get null as a root, right?
Mm-hmm.
Like can be root,
Mm-hmm.
and can and the tree is not anything special about it. Like for example, it's not a completed tree. It can be in any form, right?
That's correct, yeah.
Okay. And all the uh, values of the tree are integers always. Is that correct?
Yes, let's assume that.
Integer values. Uh, of integer values, and these integer values can be positive or negative,
Mm-hmm.
and it is possible that I have duplicates.
Mm-hmm.
Uh-huh. Yeah, for I'm not seeing any any point that I need to clear now, but I may ask later. So
Sure.
since the questions tell me in each row of the tree, it means in each level, right?
Yeah.
Each level, I need to get the maximum. So if I do a level order traversal of
Mm-hmm.
my tree, and at each level, I just calculate the maximum. So yeah, like a breadth-first search or level order, I can use a queue. I
Mm-hmm.
initialize my queue with the root. So
Mm-hmm.
obviously root is just one element. When I pop the when I have a queue,
Mm-hmm.
it means that's one level.
Mm-hmm.
So at first I have one in my queue. In my queue is one.
Mm-hmm.
So I know there's a level. So I calculate the maximum of the queue.
Yeah.
Oh, the max is one. And I make the queue empty and go for the next level. The
Mm-hmm.
next level of one is gonna be 3 and 2. So
Mm-hmm.
now it's time for me to visit it. 3 and 2, the maximum is 3. Okay, and then I clear out the queue. Go to the next level and put everything in the queue. It's gonna be 5, 3, 9. what is the maximum of these is 9. I clear at this layer.
Hey, just
Go
give
to the
me
next
a second. Give me a second. I'll just
Sure.
start. Hey, sorry. Yeah, back.
Yeah. So what I have, the first idea come to my mind is do a level order traversal.
Mm-hmm. Yeah, I think I saw
Initial.
how you were adding things to the queue. I have a question there. So, you were initially, so you went from level one, then you added nodes for level two in the queue, like three and two. My question there is that after adding those to the queue, are you kind of uh, looping through the queue to understand what's the maximum value? Or how is the maximum value being calculated? Is it like once you pick out a node from the queue, at that point you check whether it's max or not? Or is it that you're kind of doing it together for all the elements of a level?
So yeah, my initial thought was that I have everything in the queue, so I have to loop through the queue
Mm-hmm.
one time and get the maximum, calculate the maximum.
Okay.
So that's one way. But I was actually thinking if I want to optimize that, maybe as I add to the queue for the next level, I also keep track of the maximum. So I
Mm-hmm.
have a value like max val in the current level. At first is negative infinity,
Mm-hmm.
and then when I have one, I'm going through my node is one, and I
Mm-hmm.
want to get the next level. So one, the left node is gonna be three. Three is greater than the put it here, and the other node is two. Two is not, so I have three. So and then when I come to visit this level,
Mm-hmm.
I know the maximum already is three. So
Mm-hmm.
I add it to the output.
Okay.
And then now I have to do the next level, which is gonna be come from three and two.
Mm-hmm.
Next level come from three and two. I again this negative infinity. At first it's gonna be five, then it's gonna be three. Three is not greater than five, so I keep the five.
Mm-hmm.
Then I have two. Two has nine. Nine is greater. I have nine. So my next is gonna be nine. So when I come here to the next time to visit my level,
Mm-hmm.
I know the maximum already. So
Gotcha. Okay. Um,
uh, if
all right.
I do
Mm-hmm.
this,
Mm-hmm.
um, if I do this, it means I am going through each node one
Mm-hmm.
time
Mm-hmm.
using my level order traversal.
Mm-hmm.
So if n is number of nodes, I'm gonna have O of n,
Mm-hmm.
which is O of n time complexity.
Mm-hmm.
For the space complexity, I need to know this queue that I'm maintaining, what is the maximum size of it.
Mm-hmm.
So the maximum size of the queue is when I have it's sort of like a complete tree, and for example, a complete tree
Yeah.
and number of uh, leaves in that complete tree. So
Mm-hmm.
number of leaves in a complete tree is, let me calculate it. Is if I have one node, it's gonna be one. If I have three nodes, it's gonna be two. If I have another level, it's gonna be four, right? And it's gonna be eight. Uh, so each level add and make it double.
Mm-hmm.
So in a complete tree, the space complexity uh, N is the number of. I know in a complete tree, the number of levels is log n
Yeah, that's
if
true.
n is an object. So, and each at the n last level is gonna be log n times 2. What, is that correct? So if I have the third one, 1 is 1, 2 is 2, third is 4, 4 is 8. Uh, Let me see. It should be. I'm trying to see if it's a good way to calculate the space complexity through the number of levels or actually through
Yeah,
the
so
number of nodes.
yeah, I think in the end you need to figure out in terms of n itself. So maybe try to look at it from the angle of like you were trying to figure out how many nodes your queue will have if it was a complete tree, right? Of 3 levels, 2 levels, so on and so forth. So if it's 3 levels, now you have, you're gonna have 4 nodes in the queue, in the worst case. But how many total nodes would be there in that?
Uh, Sorry, how many total nodes in the queue?
Yeah, if it's like a complete tree of 3 levels, how many total nodes are there in the queue?
So it's gonna be 4.
No, that's in the
It's
queue, right? And how many total nodes are there in the tree?
n.
Yeah, what is n in that case is what I'm saying. Like you can try to
Oh,
relate.
I see.
Yeah,
7 nodes. It's gonna be 7 nodes. Give me 4.
mm-hmm.
Uh, so it's gonna be 7 plus 1 divided by 2 is, does that work? So if I generalize it as n plus 1 divided by 2? 1 plus 1, 2 divided by 2 is 1, 3 plus, oh yes, yeah, it works actually. Yeah, so space is going to be O of n plus 1 divided by 2, which is like in terms of yes, time complexity is O of n.
Right. Mm-hmm.
Yeah.
Okay.
So yeah, that will be my approach. If you think sounds good, I can
Yeah, it
implement
looks
it.
good. I think we can definitely see the code. Yeah.
Uh, have a root of my tree and initialize the result array. And if root doesn't exist, I just return the empty array and initialize my queue as root inside and say while queue here and initialize max so far. It's gonna be root dot value. Uh, so here I will append the max so far. This is the time to visit each level and maximum so far I have it and this and I empty the queue. So this is a temporary queue because I want to add all the next level in this queue. So then for each node in the queue, so I do that. I have to reset the max so far. to negative infinity. And we said for each node, if start from the left to right, if node the left exists, and let's see the max, update the max so far. And then I push it to my queue. Then go to the right node, do the same thing. And return the result. So let me run an example on this. So this example that we have at the top. So first my root is 1, so Q has 1, and max so far is 1. So I append to the result 1. Max so far now it's become in negative infinity, and then I go to the next level, left is 3. So negative max so far is going to be 3. I push the 3 to the cube, and go to the right. Max so far is not going to be changed because 2 is less than 3. Push the right, which is 2. And then I have 3, add 3 to the result. And start with 3 then for the next level. And 3, I'll also reset the max so far. And then note the left is going to be 5. 5 is going to be the max so far. And note that push the 5 to the queue. And then going to be 3. And 3 is going to be not going to change the max so far. And push the 3. And then going to be 2 dot left. 2 dot left is null. So I'm going to go to 2 dot right. 2 dot right is 9. It's going to change the max so far to 9. And then push the 9 to the queue. So then I come top to the line 150. I know the max so far is 9. I push the 9. And then I reset the max so far infinity, and I go for each node, which is going to be 5, 3, 9. I'm going to their children. Their children doesn't exist. So Q gonna be empty. I'm out of the loop. I return the 139 as output. So it works for this example. If I'm thinking, I want to think about any other cases. If its root is null, I have I return the empty array. And if, I think I'm not seeing any weird case that cause problem. I can have negative values. It still is fine because I set my max so far to negative infinity. If you have any questions for me,
I think this looks okay to me. Okay, let's stop the interview here. We are a little early. You still had like 2 minutes left. Okay, so how did you think you performed before I give you the feedback that I've written down?
I think I think it went well. Yeah, I'm pretty happy that I heard feedback from you for both of them. You said it looked good, so.
Yeah. So let me just tell you, TLDR version. If this was the real interview, you will get a higher signal with a very strong confidence. So we when we are giving out actually submitting your review for the interview, we have to along each of the axes we kind of suggest is it like a higher signal or is it like a no higher signal, and how confident are we about speaking
Mhm.
about higher or no higher. This would definitely be among one of the strongest interviews that I've had on especially on this platform. I think you're among the best candidates that I've seen. Honestly, at some point I was feeling that maybe I could have thrown a hard question at you, just to maybe discover some things that where I would have been able to help you out with, because right now it just seems too perfect to suggest something which could be better. You kind of ticked off all the boxes that a perfect candidate would. So let's go one by one and let me just cover these things.
Mhm.
At least so you get to know that all the things that you're doing which are good and which are noticed, right? So on the angle of communication, from a communication perspective, you asked very good clarification questions at the start of the question. You also think about edge cases then and there itself. That's all good. You spoke about the and space complexity yourself for each solution that you were talking about. That's also pretty good. And you knew about them. And generally, your communication skills are among the best that I've seen. You not only do you speak very clearly, and not only do you talk about the way you'll be doing things, you also use the comment space very efficiently. You make sure that visually you are putting out whatever you're saying in the most clear manner for the interviewer. So I don't see any way any person would have trouble understanding what you're saying. So those are
Mhm.
all good things. I have no gripes here at all. Um, the only thing I would suggest is, in case you feel that um, the question is too hard, or that you are low on time, right? Because in this
Mhm.
case it worked out. Most likely it will work out given you're gonna appear for E3 or E4. You will most likely not get a hard question. Okay, I'm not guaranteeing this because it depends on the interviewer
Mhm.
what questions they choose. But for an E3 or E4, and especially on a phone screen round, generally it would not be a great idea as an interviewer to throw a hard question. For an on-site, perhaps it still appears with very less probability compared to a medium level question, right? Most likely you'll get medium level questions. There's chances you might see the first question as being an easy level question also. I asked both questions which were medium level, but there are chances that you might even encounter an easy question on as your first question. Now, keeping all of
Mhm.
that in mind, yeah, so overall, your communication skills are great, but because you're spending a lot of time making sure that everything's understood well, remember that if you feel that you're low on time, and it's good that you try to check that with me as well. You can do that in the real interview too. If you feel at any point that you're low on time, it's okay to skip on few of those things, right? It's okay to not go out of the way to explain everything very nicely, just so that because more than that communication, what's going to matter is that your code is correct, that it's complete, and then that you did some sort of a dry run to verify, and you've come up with a test case or two yourself and you've verified your code. So those things have higher weightage than just discussing the solution or coming up with a solution. So a lot of people still get high confidence, higher signals if their discussion part was not that great, communication skills were not amazing, but they were able to explain that they came up with the optimal solution, just that they did not highlight it in the comment space very efficiently. Okay, so I'm saying that's the place where you can take a hit if you feel you're low on time. Okay, Otherwise, this
Mhm.
is perfect. Try to keep it like this. That's all you need to do. Um
Mhm.
Technical knowledge side, again, you knew about linked list, you knew about breadth first search, you knew about queue, how you implement that with a queue. You could answer about time and space complexities for both questions. In the second question, there was a tiny hint that I had to give you to think about space complexities the right way. But you were going in the right direction. And these kind of tiny hints do not really will ever make you make it a red signal for hire. So the entire idea behind interviews is that we are trying to evaluate if we, um, in fact, if we give you a hint and if you can catch on to it, that's a positive signal. That's not negative signal. If there are like too many hints, maybe like
Mhm.
10, 15 hints that if given in the round, that's where it becomes a problem, right? Because we are the ones who are leading the discussion. In this case, you were leading the discussion almost entirely. So it was all good, no major issues. Uh, Problem solving skills. So again, one of the I have literally written this was absolutely perfect because you led the discussion. It was more like a presentation, less of a back and forth discussion. That's the best way a coding round could be, wherein you have figured everything out. You're just explaining how it would work to me or to the interviewer. You talked about the brute force solution. You discussed its complexities. You talked about optimal solution. You discussed its complexities. You kind of showcased how that will work in comment section, and then you asked whether this looks good, and you can jump to coding. And that's the perfect way. Then writing down the code. So for both the questions, you did well on that front. You were able to come up with optimal solutions yourself. I did not have to give you any hints or guide you in any way. So all of that was amazing. Coding skill side, code looks to be clean. For both the questions, I have no issues. The only small thing that could have been improved in the first question is that you just the variable names. So one is that instead of P1, P2, you could have chosen slightly more semantically meaningful names, maybe like even pointer, odd pointer, because that's what they were representing. Something along those lines would have made slightly more sense. That's the only thing. Um, uh, in the second question, I don't see that issue reappearing. So it's not that you're going to do that always, but it's just something, a small issue that I could point out. You did cover edge cases in both the questions. You were able to fix your code. There was a small logical bug which you fixed yourself in the first question, so I have no issues there. Both code seems to be pretty good. They will work. And another good thing was that your dry run quality is quite good as well. The way you in both the questions, how in the first question you adapted the way of writing down uh, the the difference in your linked list one after another, which is good. And in the second question, you took the approach of just describing the value of a particular variable as an inline comment. Both are good dry run approaches. You can use either of them, and it's good that you use the one which was better for a particular question at the better at the right place. So again, no issues
Mhm.
here. Keep doing like that. Um, what else? Yeah, one more thing is you do tend to speak out when you're coding. So you're kind of explaining the entire code as you're writing it down, which also helps
Mhm.
keep the interviewer engaged. So keep doing that, because that way an interviewer is not going to have questions around a particular piece of code or a particular part of the code later on. And you're avoiding a back and forth discussion, which helps save time and give you more time to basically solve the question and do everything. So this was one of the best interviews that I've ever had, honestly. And the only thing is that as an interviewer, especially a mock interviewer, there's not much improvement feedback that I can really give if you perform this well. So that's the
Mhm.
only thing. How it is like.
Okay.
But you definitely seem ready. You could have a interview tomorrow, or for all it. for yeah, for all intents and purposes, and you'll still do well, I think. Yeah.
Okay, I'm glad to hear that. Thank you very much for all good feedback. One last question I have is, what do you suggest for practicing these questions? I've been using lead code.
Yeah.
Do you think should I go through like all the Facebook tag lead code problems, or do you have any other platforms you suggest me to use?
Yeah. So I think lead code is the best one. 90% of the questions that get asked are already available on lead code. There might be like 5 to
Mhm.
10% questions that maybe are not there, but then they show up there after soon enough. No matter whichever new questions we create, they often end up on the lead code platform within a couple of months. So most of the questions are covered. You should definitely target all the Facebook tag questions on lead code. Buy its premium account if you don't have it, and sort them in the order of uh, frequency. The reason I say that is usually interviewers have a small pool of questions. Like every interviewer is gonna ask maybe same 5 or 6 questions to almost all candidates that they interview. Uh, they That's the usual case, and there are far too many interviewers in at Meta. So what happens due to that is that if some questions are being asked too many times, that's gonna keep continue happening because maybe a large chunk of the interviewer population asks those questions, and that's not going to change anytime soon either. So because of that, it would be good to follow the frequency order that lead code provides as well, and start solving from top to bottom. A usual suggestion that I give is that I've seen candidates who are able to do well on these rounds have usually solved close to 100 to 150 questions before phone screen, and maybe around 200 questions by the time they give their on-site rounds. So if you're able to get to that number, that would be amazing. And but I feel that you're ready, at least with the question that I threw at you. You seem to be quite ready. Um, but yeah, that's the advice I can guess. Yeah.
Okay. Yeah, yeah. And so you said the probability that I get hard questions is
Right.
not that high. So I
Yeah, not
shouldn't
that
really
high.
spend too
Not
much
that
time on
high.
it.
It's just that even if you get a hard question, remember that most likely it's not going to be the first question. Generally, a hard question will be thrown with an easy question, and the easy question would be the first one. It's not like the interview is going to give you the first question as the hard question. That's very
Hmm.
unlikely. Like the reason for that is it's kind of against the guidelines that we are given. So technically, an interviewer could do that, but it would not really be following the kind of guidelines or the kind of um, uh, uh, suggestions that have been given to interviewer when they get trained for taking interviews. What we are told is that you
Hmm.
keep the first question's complexity lower than the second one, generally, or keep them at an equal level if you feel both can be solved around in the same time. Um, so if you get a hard question, that's going to be second question. And if you get a hard question, do remember that it's for a phone screen, to clear the phone screen, it's not always necessary that you're able to solve the two questions as completely as you did here. Even if you get very
Hmm.
close to, say, just completing the code of second question, you've not done the dry run, you've not fixed the code, but you've gone to the point where you've discussed the optimal solution and you've maybe coded like 50, 60, 70% of the code, um, and the time runs out. Even then, you will get a higher signal from a phone screen. Okay, so you will get a pass to go on for the on-site. Um, in the
Hmm.
on-site, because the reason is that in such a case, it's like a borderline, right? You were not able to solve two questions, but at the same time, we do have enough signals that you can solve these questions. You can come up with the case, and if you had another 5 minutes, you might have solved the question completely. So, if we know that all that is needed is perhaps more practice. so that you can be slightly faster. And you can definitely do that before scheduling your on-site. So if you are in doubt, you still get a higher signal in a phone screen. But in on-site round,
Mm-hmm.
if you are in doubt, you're not gonna get hired. So that's the difference. In phone screen, if you are in doubt, you get benefit of doubt. In on-site, if you are in
Mm-hmm.
doubt, you're not gonna get the benefit of doubt.
I see. Makes sense. Yeah. One last question is that common that the first question, which is like whatever it is easy or medium, and the second question is like built on top of the first, like is in the same area they
Mm-hmm.
assess me.
Yeah, so
Is that
that's a very
common?
good question. Can vary. I know people who ask questions that way, wherein the second question builds on top of the first question. And then I know interviewers who will, uh, by design, not do that. I am one of those people. There are reasons behind both. The first one, kind of, the thinking behind the first one is that it feels more natural, more smooth of a transition, that you're just adding more complexity to the first question. Just looks more, looks and sounds and feels more sophisticated and natural, that you're kind of discussing the same problem, just adding more complexity to it. um, so that's why a lot of interviewers do that. I think there are more interviews, however, who will not do that and who will basically give you two different questions. The reason behind that is that they are trying to judge, they're trying to get more signals from you. Um, because what if you just know how to solve linked list questions, but you don't know anything else? Or if you on the other way around, maybe you are, maybe one of the, like the question that we gave you, maybe linked list is your weak point, so you are not able to do well on that. But as soon as we threw a question from a different area, you were able to nail that immediately, right? So asking two different questions gives us that advantage that we can get signals on how diverse of a knowledge do you process. Or maybe if uh, just because of bad luck we asked a question from the area that was not your strength. So in that case, maybe you didn't
Mm-hmm.
perform well in first question, but then you showcase a lot of positive signal in the second one. That gives us the positive signals that we need. So entire idea at the end is that can we get enough positive signals to realize that, hey, this guy would be able to work at Meta, and we'd be happy to
Mm-hmm.
have them here, right? And if we ask two different questions, there are two independent um, opportunities that you get to prove that. So that's why me and a bunch of other interviewers will choose that instead of the approach where the second question is just a added complexity on top of the first question.
Mm-hmm. Yeah, yeah, makes sense. Yeah. Thank you very much for your time. Yeah, this
All
was great.
right, man. All the very best. I will submit whatever I just spoke of in the written form as well, so you can have a look. But I think you don't need to have a look. You just nailed this round. I wish you all the best. I think
Thank
you'll
you
do
very much.
well. And I hope to see you at Meta down the road.
Thank you. Thank you very much. Really
All right.
appreciate that.
Okay. Bye
Have a
bye.
good day.
You too. Have
Bye.
a good day. Bye bye.